write that on top of y'all. I'm running out of usable space. Power. Also known as, anybody? Powers are also called what? Starts with an E and ends with exponent. Exponents. So if you have this, let's say you have 7 to the second power, or also called 7 squared. This is what you need to know about this. This is the base number, and this bad boy right here is the exponent for power. Okay, and I will tell you, I will warn you, and you'll still do this. I can tell people 1,000 times and they still do this. The most common mistake people have when they do exponents is they think the answer to this is 14, and it's not. Because the rule with exponents is this, okay? An exponent tells you how many bases get multiplied together. The exponent tells you how many bases get multiplied together. It's not 7 times 2, but in this case, I'll write it over here so you can see it. 7 squared means that you have 2 7s times themselves, which is 49. Exponents generally give you very large numbers. If you ever hear the phrase that something grows exponentially, yes, that means it starts slowly and starts getting big really fast. Because if we went to 7 to the 3rd power, well, 49 is not too big of a number. If you multiply 3 7s times themselves, you'd have to multiply 49 by 7. By the way, what's a fast way to multiply? What's a fast way, Sam, to do 49 times 7 in your head? Not that you should have to. Anybody? Rather than going, okay, 7 times 9 is 63, and then carry the 6, and 28 and 6 is whatever there. Quicker way to think about it would be to think outside the box a little bit. Aiden?
7 times 50.
7 times 50, which is 350, and then what would you have to take away from that?
7.
7, because 1 times 7 is 7. So what's 350 minus 7?
Is 143.
How about 343? If you're doing it in your head. Now, granted, that's not something I would think that, it's great to do in your head, but it is something you could think about when you get older in life. Now, some special cases, special instances. Write this down. Special cases. If I have 7 to the 0 power, again, people, you tend to get this one wrong all the time. What do you suppose 7 to the 0 power is, Ronnie? 0. It is not 0. Ephraim?
7.
It is not 7. And those are the 2 common mistakes there. 7 to the 0 power. Danny is?
1.
It is 1. Which is our next thing you need to write down. Anything to the 0 power is 1. Anything, no matter what it is, anything to the 0 power is 1. You can have 5,280, you could write it, 5,280 to the 0 power, and that equals 1. You could have the letter A to the 0 power, and that equals 1. Anything to the 0 power equals 1. Did I say that enough?
Mm-hmm.
Now, one more here, over here. What about 7 to the 1st power? 7 to the 1 power. This one equals, Charles?
7.
It is 7. And the rule with the 1st power is this. Anything to the 1st power is itself. Anything to the 1st power is itself. 58 to the first power is 58. Usually we don't put the little 1 up there because it's just itself. There's no point in putting 58 to the first power because it's just 58. So you just write 58. And then with that being said, we just have to do a couple more things with powers before we get to exponents. Let's say you have 2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth power. If it's something to the second power, a lot of times instead of saying the second power, we say the word squared. 2 squared is what this would be. And something to the third power, instead of saying third power, we say cubed. 2 cubed. And to the fourth, anything after that, we just put whatever, fourth power, fifth power, sixth power, seventh power, fifth, sixth, seventh, and eighth. You know, if it's something to the 22nd power, these are the only 2 really we have special names for, squared and cubed. Most because we use those when we find cubic area and volume and all that sort of stuff. Das ist gut. So they'll ask you to do something like that. Let's break down one more example. They'll say use exponents. So they'll give you something like this: 3x, x, y, y, y. Rather than writing all those x's and y's, it would be 3x squared y cubed. This is kind of how we write it more simply, because you don't want to sit there and have to count all sorts of letters and numbers if you're multiplying them together. Good for you, good for me, good for everybody. Perfect. Now, blank piece of paper, we have to go to roots. Get back to your roots, as they say. Trying to get some upper level mathematics here. And that would be this. The parts of the roots whole thing are these. Make sure you get these labels down. This bad boy right here is called the radicand. The little sign we use for a square or a root sign, please understand that is not division. This is not 8 divided by 3. That's what a lot of people do, they make a mistake. This is the radical sign. And this number 3 is what we call the index number. There's not an easy way to explain what this means in words. It's a really simple thing, but it's not easy to explain. But the best way I can explain it is this. The index number tells you how many of the same number you multiply to get the radicand. Does that make any sense? To get the radicand. The index number tells you how many of the same number you multiply to get the radicand. Let me talk about that right now. Which means if you have the cube root of 8, which is what we say when we say this, the cube root of 8 means you have to think about what same number multiplied by itself, and you have 3 of them, will give me 8. And let me tell you, ladies and gentlemen, there's no easy way to do this. There's no algorithm. It's simply trial and error. And that's all you can do. And you stick a 1 in there and you say, okay, 1 times 1 times 1, that's 1, so it's not that. You put a 2 in there, 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. That's what the answer is. This is what it would look like. The cube root of 8 is 2. Just 1 2, not all 3 2s, whatever, it's just 2. Verse, does that make sense? Now we don't, if you come up with this. If there is no index number, if there's no number up in this little corner, no number is a 2. If you don't see a number up there, it's an assumed 2, and we call that the square root of 16. We call that the square root of 16, which simply means what number times itself gives you 16, and that would be 4. Again, please remember, this is not division. This is not division. Your brain's full yet? Because we've got some more to do here. With this, we also have to look at what we call the perfect squares. Because there are billions, an infinite amount of square roots, 99% of them don't work out to anything nice. The ones that do work out to something nice, we call the perfect squares. And see if you can catch on to this. Let me just do a bunch of them. Square root of 1, square root of 2, square root of 3, square root of 4, square root of 5, square root of 6, square root of 7, square root of 8, square root of 9, square root of 10, square root of 11, square root of 12. The perfect squares, ladies and gentlemen, are the ones that you can actually give me an answer to. Okay. And for example, is there a square root of 1? Is there some number times itself that gives you 1? Yes, it's 1, because 1 times 1 is 1. This is a perfect square. Square root of 2. Is there a number times itself that will give you the square root of 2? Give you 2. What times what gives you 2? Riv? 2 times, no, it's got to be the same number. Huh? Then no number. What times what will give you 3? Nothing, not the same number. How about 4? Yes, 2. 2 times 2 is 4. No number will give you a 5. No number will give you a 6. No number will give you a 7. No number will give you an 8. However, 9 is 3 times 3. No number will give you 10. No number will give you 11. No number will give you 12. These are the first 3 perfect squares because they work out. Now, just because you're smart people, I will tell you this. What about the rest of them? The rest of these numbers that don't work out are what we call irrational numbers. Any idea why they're called irrational? Is it good for you to be called irrational? Not usually. They don't make sense. The reason they're called irrational is because they don't work out, and you cannot get an exact answer for them. You can get a calculator, and you can tell it to find the square root of 6, and you get a never-ending, non-repeating, I don't have pi up here, decimal number. You cannot get an exact, perfect answer for that, which is irrational to us because we like to rationalize things. Now you can get close, ladies and gentlemen. I could ask you to estimate the square root of 2. And when you ask to estimate, I'll give you this little squiggly equal sign, which means is close to. What would you know that the square root of 2 has to fall between what 2 numbers? It has to fall between these 2 perfect squares. Because it's in between these 2 perfect squares. And it looks like it's closer to 1 than it would be to square root of 4. So no, I mean my guess, I wouldn't guess 1.5, I would guess 1, I don't know, maybe 1.2, 1 point whatever it is. What is the square root of 2, you ask? What is the square root of 2? Let's grab Mr. Calculator. Here comes our square root of 2. 2 square rooted. 3 point, wait, that's a 1, sorry. 1.414. I did do that, right? Did I push the wrong number there? I can't see. Oh, wait. It is, yeah. It's approximately, because again, I can't put completely equal. Where'd it go?
It disappeared.
That's not equal. 1.414. Which means if I gave you the square root of 2 amount of dollars, you'd get $1.41. If I asked you to estimate the square root of 8, what is your guess on the square root of 8? Kevin Wills, what would you guess the square root of 8 would be close to? Well, you know it's got to be less than 3, because that's what the square root of 9 is. You know it's got to be more than 2, because that's the square root of 4. That's the next. Those are the 2 perfect squares it falls between. Your guess is 2.5. You're guessing.
Yeah.
Ephraim is guessing
2.9.
2.9. Let's see what the square root of 8 actually ends up being. 2.828. It's interesting how it's 2 times that, which doesn't make sense, because 2 times that is not just square root. It's not how square roots work. You gotta be careful. Got that? So if I asked you to estimate this, let's go one step farther on the estimation train. By the way, let's list the perfect squares, because it won't take us very long to do it. Square root of 9, what would be the next perfect square? Which would be what 4 times 4 is. Brandon?
16.
16. What would be the next perfect square, which would be 5 times 5? 25. Next perfect square? 6 times 6 is next perfect square? 49. Thank you. 7 times 7. And then 64. 81. And 100. Those are what are the first perfect squares, the first 10 or 11 perfect squares. So if I asked you and I said I have the square root of, I don't know, 28, you should be able to estimate for me what that's close to, because the square root of 28 falls between these 2. So your answer has to be between what 2 real numbers, or rational numbers, I should say. Yeah, got to be between 5 and 6. Maybe you could guess it's closer to, probably closer to 5 than it is 6. You know, maybe it's what? 5.3? Let's try. Square root of 28. 5.3, 5.2. There you go, kids. You are now pretty much experts. Another thing. Is there something special we need to know? I think that'll probably get you there. GameStop is crazy.